Welcome to our channel. Today we're diving into the cosmos to uncover some mind-blowing facts about space that you probably didn't know. From the heights of Martian volcanoes to the depths of neutron stars, we'll be exploring the wonders of the universe and grappling with concepts that stretch the limits of our imagination. So buckle up and get ready for an interstellar journey.
Our first stop takes us to our red neighbor Mars, home to Olympus Mons, the largest volcano in our solar system. Imagine a volcano so massive it dwarfs Mount Everest 3 times over. That's Olympus Mons, a shield volcano that stretches across an area equivalent to the entire state of Arizona. Now you might wonder, how did this behemoth grow so large? The answer lies in Mars's lower gravity and the absence of plate tectonics. On Earth, tectonic plates constantly shift, causing volcanoes to erupt in different locations over time. But on Mars, Olympus Mons remains stationary over a volcanic hotspot, erupting and growing for billions of years. The sheer scale of Olympus Mons is a testament to the incredible forces that shape our universe.
From the largest volcano, we shift our gaze to the vastness of space itself. When we look up at the night sky, we see a smattering of stars, a celestial tapestry woven across the darkness. But what we see is just a tiny fraction of the stars that actually exist. Astronomers estimate that there are more stars in the observable universe than grains of sand on all the beaches on Earth. The next time you hold a handful of sand, imagine each grain representing an entire star, each with its own planets, moons, and perhaps even life itself. The sheer scale of the universe is almost impossible for our human minds to grasp. Somewhere out there, amidst the trillions upon trillions of stars, other worlds must exist, perhaps even harboring life as we know it, or as we've never imagined it. The search for these worlds, for signs of life beyond our pale blue dot, is one of the most profound quests we can undertake.
Our cosmic journey now takes us to Venus, our closest planetary neighbor. But don't let its proximity fool you. Venus is a world of extremes, shrouded in a thick, toxic atmosphere and boasting surface temperatures hot enough to melt lead. But Venus holds another intriguing distinction. A day on Venus is longer than a year on Venus. How is that possible? Well, Venus rotates incredibly slowly on its axis, taking a leisurely 243 Earth days to complete one rotation. However, its orbit around the Sun is much faster, taking only 225 Earth days. This means that a year on Venus, the time it takes to complete one orbit around the Sun, is shorter than a single Venusian day. Imagine living on a planet where the Sun rises in the west and sets in the east, and where a single day lasts longer than an entire year.
Prepare to have your mind blown as we delve into the realm of neutron stars, some of the densest and most extreme objects in the universe. Imagine a sphere no larger than a city, yet containing more mass than our entire sun. That's the incredible density of a neutron star. These stellar remnants are born from the explosive deaths of massive stars, collapsing under their own gravity until even atoms are crushed. Some neutron stars, known as pulsars, can spin at rates of up to 600 rotations per second. Imagine the forces involved as these cosmic whirlwinds spin at such incredible speeds, beaming out radiation like celestial lighthouses. The study of neutron stars provides us with invaluable insights into the nature of matter under extreme conditions, pushing the boundaries of our understanding of physics.
Diamonds are a girl's best friend, as the saying goes. But what about a planet made of diamonds? That's no longer the stuff of science fiction. Meet 55 Cancri e, a planet twice the size of Earth located about 40 light-years away in the constellation Cancer. This exoplanet orbits incredibly close to its host star, 55 Cancri, completing an orbit in a mere 18 hours. But what makes 55 Cancri e truly unique is its composition. Scientists believe that this planet is largely made up of pure crystallized carbon. Now, under the immense pressure and heat deep within 55 Cancri e, this carbon would form a giant diamond, a sparkling jewel on a cosmic scale.
In 1969, humanity achieved a monumental feat setting foot on another celestial body. The Apollo 11 mission marked a turning point in human history, And the images of Neil Armstrong's first steps on the lunar surface are forever etched in our collective memory. But here's a fascinating thought. Those footprints, those iconic impressions in the lunar dust will remain undisturbed for millions of years. Unlike Earth, the moon has no atmosphere to speak of, no wind or rain to erode those historic marks. The only forces at play on the lunar surface are micrometeorites and the constant bombardment of solar wind, but these processes work incredibly slowly. So those footprints, along with the lunar rover tracks and other artifacts left behind by the Apollo missions, will serve as silent testaments to humanity's reach into the cosmos.
Let's revisit those mind-boggling neutron stars for a moment and delve deeper into their incredible density. We already know that a neutron star packs more mass than our Sun into a sphere just a few miles across. But to truly grasp the concept of their density, consider this. A single teaspoonful of neutron star material would weigh about 1 billion tons. The immense gravity of a neutron star crushes its atoms, forcing electrons and protons to combine and form neutrons, hence the name. The result is a material so incredibly dense that it defies our everyday experiences. The study of neutron stars and their extreme properties helps us understand the fundamental nature of matter and the forces that govern our universe.
Who knew that space could be so intoxicating? In 2006, astronomers made a surprising discovery: a giant cloud of alcohol floating in space. This massive cloud, located some 10,000 light-years away in the constellation Aquila, contains enough alcohol to make trillions upon trillions of liters of beer. But before you start planning your next interstellar pub crawl, it's important to note that this alcohol isn't the kind you'd want to drink. It's primarily composed of methanol, a simple alcohol that's toxic to humans. However, the discovery of this giant alcohol cloud is significant for other reasons. It provides clues about the formation of complex organic molecules in space, the building blocks of life itself.
One of the most mind-blowing concepts in astrophysics is the fact that our universe is not static. It's constantly expanding. This expansion was first observed by astronomer Edwin Hubble in the 1920s, and it has profound implications for our understanding of the cosmos. Imagine baking a loaf of raisin bread. As the bread rises, the raisins within it move farther apart from each other. Similarly, as the universe expands, the galaxies within it are moving away from each other. But here's the kicker: the expansion of the universe isn't just continuing, it's accelerating.
Our final stop on this cosmic journey takes us to Europa, a moon of Jupiter that harbors a tantalizing secret: a vast, subsurface ocean of liquid water. Europa's surface is covered in a thick layer of ice, but beneath this icy shell, scientists believe there's an ocean that may contain twice as much water as all the oceans on Earth combined. Now, where there's water, there's the potential for life. Europa's ocean is thought to be salty and may even contain more water than all of Earth's oceans combined. It's a prime candidate for harboring extraterrestrial life, perhaps even more complex than the microbial life we hope to find on Mars. Scientists believe that Europa's ocean is heated by tidal forces from Jupiter's immense gravity, keeping the water liquid beneath the icy surface. Future missions to Europa will hopefully confirm the existence of this subsurface ocean and search for signs of life in its depths.
Thanks for watching. If you enjoyed this journey through space, don't forget to like, subscribe, and hit the bell icon for more fascinating facts. The universe is full of wonders waiting to be discovered, from the largest stars to the smallest particles. So, keep looking up, keep asking questions, and never stop exploring the cosmos. Until next time, remember that we are all made of star stuff, and the universe is ours to explore.